Now that we've learned about pixels and how images are represented as a two-dimensional list of pixels, and now we've learned about black and white images, let's talk about grayscale images. Grayscale is probably what you were thinking of when you heard black and white at first, which is maybe what you see in any photos of your grandparents or great-grandparents or figures in history from black and white cameras, where the colors that are possible for the image are any shade of gray, where the darkest shade of gray is black and the lightest shade of gray is white. So for grayscale images, instead of just being able to have a value of 0 or 255 for the pixels, we allow any value between 0 and 255. So you can see here the same thing. The darker a color is, the darker a pixel is, the lower its brightness value. And so a black pixel still has a value of 0. A white pixel still has a value of 255. But you can see here, like this color down here is very close to black, but not quite black. It's kind of grayish. And so it has a value of 15. So a very low brightness, but not 0. And inside of Pikachu's face here, like the color of Pikachu's face here, is not white like the eye here or like the background. It is actually slightly off-white, and so it's a pretty high number, but it's not 255. It's 186. And so in class today, we don't have time to do this in the video, but in the classwork, I'll ask you to make a grayscale gradient. And these gradients are cool. You probably have seen them if you've ever worked with Microsoft Word and the word art, where you start from one color and you shift, to a different color. So here we're going to start from black at the top, and it'll shift all the way down to white at the bottom. And we do that by having rows of very similar colors. So the top row is all black pixels, but then the next row in the image is all almost black pixels. Very, very dark, but actually 1 brightness, not 0 brightness. And so on and so forth, increasing by ones until we get all the way to the widest line of pixels, the very last line. So it'll be the 256th row, so index 255, where each pixel in that row has a brightness of 255, which is the maximum brightness. We'll do this in class. Now what we've all been waiting for, which is color images. So far, each pixel has been just a single number. It's been a single brightness value. Now that we're talking about colors, we have to have some way to represent each color. And the way we do that, you might think back to elementary school and to just classes with paints. We mix colors. And we can pick 3 colors and make all of the other colors using those colors. And the 3 colors we pick are red, green, and blue. And I have it written this way here, R-E-D-G-R-E-E-N B-L-U-E, because the colors are, we often call this RGB. So red, green, blue, RGB. And so you can see here, this pixel here that's all red is defined by 25500. The first value is always red, the second value is always the green, the third value is always the blue. And each color has its own brightness. So how red is this pixel? It is maximally red. How green is it? It's not green at all. How blue is it? It's not blue at all. So for each pixel now is, instead of being represented by a single value, it's actually represented by a list of 3 values, R, G, and B. So here R is 0, G is 255, B is 0, and so we get pure green. And same thing for blue, 0, 0, 255, because it's pure blue. But notice now what we can do as we vary these values, 255, 255, 0, if you mix red and green, you actually get yellow. So yellow, the color yellow, is represented by maximum red, maximum green, and no blue. Or we can combine red and blue to get pink. So red light and blue light together is pink. And finally, green and blue light together, or colors, get this cyan color. And notice if you combine all 3 of those, I don't have it shown here, a white pixel, it wouldn't show up very well. But if you have 255, 255, 255, that is how you get the color white, which is maximally blue, maximally green, maximally red. Now, side question here, you might be looking at this and thinking, didn't we learn that the primary three colors were red, blue, and yellow. Well, weren't those the primary colors in school? So why are we using red, blue, and green, RGB, as the colors of the pixels for images? I will punt on that question and instead give you a link to someone who explains it very well right here, shortle.io/y-no-yellow. Read this post to learn more. But there's a very interesting reason why instead of yellow we use green as one of the primary colors. So here is a color image made up of pixels, and really this would be a square image here. You just kind of can't see the black pixels because they blend in. And so the black pixels around here are all 0, 0, 0. And you can even see that here. This pixel is black, and so it has a color set of 0, 0, 0. But each pixel now in this laughing emoji, this yellow color is not just pure yellow, it's slightly off regular yellow. And so a lot of red, a lot of green, and then a little bit of blue to darken this yellow a bit. It's not the brightest possible yellow. White is 255, 255, 255. This kind of lightish blue color is actually a mix of a whole bunch of colors. And this darkish blue you can see is very high blue, 175, and then some green, and then just a little bit of red. So now, to put this all together, a color image now, instead of being a single value per pixel. So our rows before were made up of a list of just integers. Each row was a list of integers. Each integer was the brightness of a pixel. We have the same thing here. Each row is made up of pixels, but each pixel is represented by a row of its own. By a list of its own. So the list is 3 colors, red, green, blue. So here we have this image with 1, 2, 3, 4 items in this list, which means that the height of our image is 4. That means that there are 4 rows of pixels in our list, in our image. And now if we look at one of these rows, one of these lists, we see that there are 1, 2, 3 items in each row. So there are 3 pixels per row, and that's what we see here. Pixel 1, pixel 2, pixel 3. Pixel 1, pixel 2, pixel 3. And so each of the pixels is represented by a list, a set of 3 colors, 3 numbers that range from 0 to 255, which are brightnesses. And the first one in the 3 is always red, the second one is always green, and the third one is always blue. RGB. So we can see for this like very blue pixel here, which is row 3, coming over here, row 3, pixel 1, the very first pixel in this list, has red be 30, green be 90, and blue be 175. So it's a fairly blue pixel. So now this is how we represent color images. It's technically a 3D list. There are rows, columns, and then for each pixel that is at a row and column, there are 3 colors, 3 brightnesses that represent that image, that pixel color. Where do we go from here? Now in class, you'll get to practice a bit more with these images and lists, nested for loops, things like that. And later this week, on Thursday, instead of the regular lab, we're actually going to be giving you a project, which will be creating Instagram filters. It should be a very fun, exciting project that'll apply a lot of concepts, basically all of the concepts that we've learned up to this point in the class. With that, I'll end today's lecture, and we'll see you in class on Monday. Bye.